In this video, I'll discuss how assignment problem can be solved using branch and bound design technique. There are n people who need to be assigned to execute n jobs, one person per job. That is, each person is assigned to exactly one job and each job is assigned to exactly one person. The problem is to find an assignment with the minimum total cost. So for this problem, the input is in matrix format. This Cij indicates whenever ith person is assigned with the jth job, the cost is given in the cost matrix. So where I and j can take the values from 1 to n. The same problem is solved using brute force design technique, that is exhaustive search approach. If there are n people who need to assign with n job, then you are required to find out n factorial feasible assignments. So from that, you are required to choose the optimal solution. So that is tedious task, because if the n value increases, then the complexity grows factorially. So this kind of combinatorial and optimization problem can be solved using branch and bound in order to minimize the time required to find the solution. So in branch and bound design technique, what you are doing here is, based on the best bound value, you are extending the branch of the state space tree. So this state space tree is constructed using BFS algorithm for branch and bound design technique. So let me see this problem here. So first, you are required to find out the lower bound. So for this problem, the best possible lower bound is, so in the first row it is 2, next 3, 1, 4, total equal to 10. So 10 is the lower bound, because look at here, A, if it is assigned, if he is assigned with job 1, he can do it with cost 9. So job 2 with 2, job 3 with 7, and job 4 with 8. The only minimum possible value is 2. So from each row, minimum possible value is taken and calculated the lower bound. The total cost for this assignment problem cannot be less than this lower bound. So we have already calculated what is the possible minimum cost. It is being computed here. So let us see how this problem can be solved so that the total cost is to be minimized. So this root indicates the lower bound, that is the least possible value for this assignment problem. Since this is minimization problem, you are required to find out the lower bound. So whenever you want to solve the maximization problem, then you are required to find out the upper bound. So start with the initial mode. Here no assignment is being made. In the first level, first person is assigned with job 1, first person with job 2, and job 3, job 4. Then find out the lower bound for each case. Okay, so A equal to 1. When person E is assigned with job 1, then the lower bound is 17. How it is 17? So person A, we are fixing job 1, that is job 1 is freezed, strike out the first column. So what remains is only 3 columns. From this, from each row, you have to choose the minimum value, because for person B, some minimum value you have to choose, and for person C, minimum value, and person D, minimum value, except the job 1. You can choose any of the remaining 3 jobs for the remaining 3 person. That too, when you are choosing, you are required to choose the minimum value. So this is the lower bound we have calculated. Then in this case, person A is assigned with the job 2. So strike out the second column. Row minimum here is 3 and 1, then 4. So total value is 10. This is the lower bound when person A is assigned with job 2. Similarly, person A with job 3. So we are freezing job 3 for the person A. So these are all the values that is in this row except the third column. Minimum value is 4. Minimum value here is 5 and here is 4. Next, finally, person A with fourth job, when you assign like this, person B is to be assigned with this job. Then C, this is the minimum value, and for D, this is the minimum value. So total value here is equal to 80. So with this, we have found the lower bound for all possible assignments of A. From that, this is the best possible lower bound. So branch out from this, that is, we are fixing person A with job 2. Okay, so here when you are fixing this person A with job 2, then for second person only 3 jobs is remaining, that is 1, 3 and 4. Okay, so let us see with 1, person B with job 1. So when you assign, the cost here is 6. Person B with job 1, the cost is 6. So strike out this column. In the third row, the minimum value is 1 and here minimum value is 4. Similarly, minimum value is 3 here. Second person with third job, the cost is 3 and minimum value in the third row is 5 and minimum value in the fourth row is 4. Similarly, here, anyway, job 2 is fixed for person A. And now we are considering job 4 for the second person. So strike out the fourth column. So what remains is first and third column. In the first and third column, so these are the values remaining. Third row minimum is 1 and fourth row minimum is 7. Okay, so with this, the lower bound is equal to 70. So now you have 3 lower bounds, out of which this is the best lower bound possible. So branch from this node. Okay. Now the left out jobs are only 2. If I assign the third person with the third job, obviously I don't have any choice. I need to assign the fourth person with the fourth job. If I assign third person with the fourth job, then I don't have any choice. I need to assign fourth person with the third job. So in this level, when 2 options is left out, so if you take one decision, alternately you have one more decision that you have to fix it. So for that reason, no need to find out the lower bound. Straight away you can find the solution in this level. So that is person C. If I assign with the job 3, then obviously I need to assign the person D with the job 4 and the total cost here is 13. If I assign third person with the fourth job, then I need to assign fourth person with the third job, then total cost equal to 25. So look at here. These 2 we are getting finally, but the solution, best possible solution is this assignment. In order to get this assignment, you have to assign first person with the second job, second person with the first job, and third with third job, and fourth with fourth job. So look at here. First with the second job, the cost is 2. Second with the first job, the cost is 6. third with the third job cost is 1, and fourth is with the fourth job it is 4. So total cost is equal to 13. The optimal solution is 13. How you can assign the jobs here in order to get this optimal value? So you are required to assign person A with job 2, person B with job 1, and person C with job 3, and person D with job 4. Then you can achieve this optimal cost. And when you are writing the solution, write in this vector format and write the total cost of the assignment.